Alright, in today's video we're looking at the volume practice worksheet for grade 9 advanced science. This is on page 39 in your science booklets. The purpose of the video is just to review formulas for volume of different shapes, also to show you how you should be putting down your work when solving a problem, and then also to review how to use unit multipliers. So quickly, first, the formulas that are used to calculate volumes. To begin with, we'll look at a rectangular prism. Sometimes it's called a box, but its fancy math name would be a rectangular prism. It's a prism because the base over here and the top over here have the same shapes. It's a rectangular prism because those shapes are rectangles. Whenever you have that kind of solid, whether it's rectangular or triangular, doesn't matter, or as we'll see next, a cylinder, there's a very general formula for the volume. You take the area of the base and you multiply by the height. So in this case, the base is a rectangle, and it has a length and a width. So the area of the base would be the length times the width. And then you multiply by the height, right? So the length times width times height, but think of that as area of the base, that rectangle, length times width, then multiplied by the height. If this were a triangular prism, so the top and the bottom were triangles instead of rectangles, you would do the same thing. You'd find the area of the base and you'd multiply by the height. But this time the base is a triangle, so you'd take the formula 1/2 times base times height for the triangle, and then you'd multiply by the height of the cylinder or of the prism. All right, so in this case, the next formula, we have what's referred to as a cylinder. It's similar to the rectangular prism up above because the top and the bottom, again, are the same shapes. So the formula is very similar. It's area of the base times the height. But this time, the base is not a rectangle, it's not a triangle, it's a circle. So the formula for area of a circle would be pi times the radius squared. And you remember the radius of a circle is the distance from the center of the circle to the outer edge. If you had the distance from one side of the circle all the way through the center to the opposite side, that's the diameter, and it's twice the radius, right? The radius is half the diameter. So area of the base, pi r squared, and then multiplied by the height again. So there, notice that those two formulas for rectangular prism and cylinder, they're both area of base times height, but the bases are different shapes. Next, we have a cone. The cone or pyramid are similar in that they have a base, and then they come to a point. So the top is not the same shape as the bottom, right? They come to a point. Now, mathematically, this was proven over 2,000 years ago. The volume of this kind of shape, this cone, is the 1/3 of the volume of a cylinder, the shape we had up above, that has the same base and the same height. So we take the formula for the area, the volume of a cylinder, area of base times height, and we just divide by 3 because it's 1/3 of that. So in this case, the area of the base is the circle again, so that would be pi r squared. Then we multiply by the height. That by itself would be the volume of a cylinder with this same radius and height. So because this is a cone, we divide by 3. If it were a pyramid instead of a cone, then it would have a rectangular base like we have up in the first example. So you'd still find the area of the base, you would times by the height, and you would still divide by 3. But this time the area of the base would have been length times width. The last object is the sphere. The sphere was proven again over 2,000 years ago to be 2/3, instead of 1/3, 2/3 the volume of a cylinder that has the same radius and the same height as the sphere. Now that formula, 2/3 the volume of the cylinder, can be rewritten, and this is how it's usually written: 4/3 times pi times the radius of the sphere cubed. Now remember that the units for volume have to be cubic units, so if you remember that, it's easy to remember it has to be r cubed, so that you get something like centimeters cubed or inches cubed as your units for volume of the sphere. All right, so let's look at the first question on the worksheet. I've sketched here the figure that's in this first question, and you're asked to calculate in part A the volume of a cylinder that's got a height of 14 feet, and then it has a diameter of 32.42 feet. And we were asked to find the volume in cubic feet. So let's start. This is how you should lay out your answers. You would start by writing the formula for volume of a cylinder. You remember it's area of the base times the height. Now if you want, you could actually write that as your starting point, but I'm going to do that in my head. The area of the base would be a circle, so pi r squared is area of a circle, times the height. And now that I've written my formula, I can put my numbers in the formula as my next step of my answer. Pi, you can either use the button on your calculator for pi. If you do that, if you have a button for pi, that's got pi with infinite number of digits. Or you can use a rounded off number. The danger of using a rounded off number is significant digits. If I use 3.14 as pi, then that limits my answer to 3 significant digits because I've rounded off pi. But when I look at the dimensions given in the cylinder, I notice that the height has 3 significant digits, 14.0. So rounding off pi like this will not affect the number of digits in my answer. So this is okay. Now I need the radius, but the picture doesn't give me the radius. It gives me the diameter instead. So what I'm going to do is show my work over on the side, and I'll say that the radius is 1/2 of the diameter, or the diameter divided by 2. So now I'll show my work with the numbers put in. This is 32.42 feet divided by 2. And that's going to be 16.21 feet. So there's my radius. Now I can put that back into the formula where we were finding volume. So times 16.21 feet squared, and then we multiply by the height, which in the picture is 14.0 feet. All right, so notice my work. Someone could clearly understand what I'm doing. They can see the formula. They can see the numbers put in. They see where I got the radius from because it wasn't in the picture. And now I'm going to pick up my calculator, and I'm just going to evaluate this. So 3.14 times 16.21. Now if you have a squared button on your calculator, you can press the squared button. If you don't, then just multiply by 16.21 again. So I'll press my squared button and then multiply by 14. And my answer on the calculator, normally you wouldn't write this answer, so let me put it in a different color. The calculator screen says 11,551.10984. That's what's on the calculator screen, but you wouldn't write that as part of your answer. What you need to do is apply the rules for significant digits and write down the correct answer rounded off. So let's look at the significant digits in the question. The height had 3 significant digits. 14.0 has 3 digits that are significant. The 0 is significant because a decimal is present, and trailing zeros count if you can see a decimal. And the diameter and the radius have 4 significant digits. So when I have 3 digits and 4 digits, and I'm multiplying or dividing, we're multiplying, you have to round off your answer to the lowest number of significant digits. So we're going to keep 3 digits in the answer. So this answer, 11,551, has to be rounded off to 3 digits. So you can pause and write down what you think it'll be. You can write it in standard form and just call it 11,600 without a decimal place. That would have 3 significant digits. Without the decimal place, the trailing zeros are not considered significant. And then the units, feet squared in the radius, times feet, the height, that's going to give me feet cubed, which are units of volume. Now you could also have put that in scientific notation. You could have written it as 1.16 times 10 to the power of 4 cubic feet. Either one of those answers would be acceptable. All right, so there's part A. Again, just take a look at what I've done. I've written my formula, I've plugged the numbers with their units into the formula. I grabbed my calculator and evaluated it, and then I rounded off the answer according to the correct number of significant digits. So that somebody reading this answer would easily understand what I did. And it's nicely laid out. That's what your work should look like in advanced science. For part B, we need to convert the volume that we just found, 11,600 cubic feet, to cubic meters. Right? So we need to convert the cubic feet to cubic meters. Now I'm going to guess that nobody here watching the video knows how many cubic feet are in a cubic meter. I don't know that. Or how many cubic meters are in a cubic foot. I don't know that. So we can't do this in just one step. All right, so we're going to do this in a few steps. Now let me go off to the side here. I know some facts that help with this. I'm going to use unit multipliers, also known as dimensional analysis, or factor label method is another name for this, to convert these units. And to do that, I need to know some facts. So here's some facts that I know. I know that I can convert feet into inches because of a fact that I have in my head. I know that there are 12 inches in 1 foot. Okay, that's an American unit. 1 foot is 12 inches. I'm familiar with that. Next, I know how to convert inches to centimeters because, again, I know another fact. I know that there are 2.54 centimeters in 1 inch. Now, that's not a rounded off number. That's exact. Just like there were exactly 12 inches in 1 foot, there's exactly 2.54 centimeters in 1 inch. And finally, I know how to convert centimeters to meters because I have another fact in my head. The prefix centi, just like in the word century, means 100. There are 100 centimeters in 1 meter. Right? There's another fact that I have. And again, that's an exact number. It's not like it's 99.8. It's exactly 100 centimeters in a meter. Now, in our units that we're trying to convert, it's not feet to meters. It's cubic feet to cubic meters. And that's important. If we were just converting feet to meters, we could use these facts that I've written once each. If it were square feet to square meters, then we would need to use these facts twice each. But because this is cubic feet to cubic meters, I'm going to use each of these facts 3 times each. All right, so let's watch what I do here. Start by writing out your answer to the last question, 11,600 cubic feet. Now next comes my unit multipliers. I'm going to use that first fact. Because we have cubic feet in the numerator, I'm going to put feet in the denominator, and I'm going to convert that to inches in the numerator. Notice that if you have feet in the denominator and there's feet in the numerator, they'll cancel out. But here we had cubic feet in the numerator, so that's why I need to use that fact 3 times. If I use it 3 times, then in the denominator, on the bottom of the fraction, I'll have feet times feet times feet. That's feet cubed. That will now cancel with the feet cubed I had originally. On the top, I now have inches times inches times inches. I now have inches cubed. So if I just stop here, I've converted my cubic feet into cubic inches. But let's go one more step. We don't want cubic inches, so we'll get rid of the inches by putting it on the denominator. That's going to cancel with the inches in the numerator. But we had 3 of those inches, so let's put the fact down 3 times. And we're going to convert that to centimeters, each of them. So now the inches, all 3 of these, will cancel with these 3. And now we've got cubic centimeter. Centimeter times centimeter times centimeter is cubic centimeters. So we've converted our cubic feet to cubic centimeters. And finally, we don't want cubic centimeters, we want cubic meters. So let's put 3 more unit multipliers. We'll get rid of the centimeters that we just wrote down, the cubic centimeters, by putting 3 of these. This will now cancel with these centimeters that we had. And we want cubic meters, so we'll use that last fact to get meter times meter times meter, which is cubic meter. Now let's put the numbers that are in those facts into the unit multipliers. A very common mistake is to just put them in the wrong place. You can avoid that by saying the fact when you're putting them in. For example, 12 inches are in 1 foot. So when you put the numbers into the unit multiplier, say it. There are 12 inches. So I'm putting the 12 beside the inches. In 1 foot. There are 12 inches in 1 foot. There are 12 inches in 1 foot. The next fact said there are 2.54 centimeters in 1 inch. So put the 2.54 beside centimeters. 2.54 centimeters in 1 inch. 2.54 centimeters in 1 inch, and you do it 3 times. And finally, the last fact, there's 100 centimeters in 1 meter. So 1 meter, put the 1 beside the meters, is 100 centimeters. Put that beside the centimeters. 1 meter is 100 centimeters. 1 meter is 100 centimeters. Now we're ready to pick up a calculator and evaluate this. We're going to start by typing in the number 11,600 on your calculator. And then notice that the 12s are in the numerators of my first 3 unit multipliers. If the number is in the numerator, you multiply by that. The 2.54s are also in the numerator, so I'm going to multiply by those also. The hundreds are in the denominators, so I'm going to be dividing by 100 3 times. Now what about all those ones? Well, if you divide by a 1 or you multiply by a 1, the answer doesn't change. So I'm going to just ignore all of the 1s on my calculator. So 11,600 times 12 times 12 again times 12 again, then times by 2.54 3 times, and then divided by 100 3 times, and you get a final answer on your calculator screen. Whoops. But remember, you have to round it off to the correct number of significant digits. We had 11,600, which has 3 significant digits. And in all of my unit multipliers, you recall, like I stressed, those were perfect. Those were exact numbers. So all of the 12s and the 2.54s and the 100s, they have infinite numbers of significant digits because they're exact. So the only number here which has significant digits that we should round off because of was the 11,600. It has 3 significant digits, so I'm going to keep only 3 digits in my answer. My calculator says 328.47, so because it's a 0.4, I'm going to round it off and just call it 328. And then the units will be meter times meter times meter, are cubic meters. There's my final answer converted. All right, so I hope that helps. If we had square feet instead of cubic feet, I would do the same thing that I did here, but only twice for each unit multiplier. We would use each one twice. If we had just feet instead of cubic feet, and we were converting to meters, I would have used each unit multiplier only once, right? So I hope that helps, both for science and math. On the worksheets in your booklets, we've just done question 1. You're going to do questions 2, 3, 6, 7, and 12 in the same way. Okay, so show your work in the same way that we did in this video. Good luck. We'll ask questions if you have any, either through Google Classroom or face-to-face if you're at school.